Now, once we are done with defining the load cases and the load combinations, we would naturally like to proceed to the stage at which we define the loads on the building. And there are many ways to define loads on the buildings, and some of them you can see on the screen right now. You can assign joint loads, you can assign frame loads, and inside the frame loads you have several options for uniform loading, concentrated loading, trapezoidal loading, and temperature loading, and you can select the load cases, etc. over there. You can also define monorail and crane loading, which we kind of saw a bit. And you also have surface loads for shells and this and that. But I want to start off with something which we call the load transfer polygons. And these are extremely powerful polygons which can be used to transfer loads on your floors, on your facades, on your roofs, or basically on any plane. As long as there's a plane available, you can use these load transfer polygons to transfer loads on that plane. So what do these load transfer polygons look like on the screen? So let me turn on their visibility from this section over here, where you can turn on the visibilities of all the objects in Comosys. And over here on the right hand side, you have floor polygons, and you have your visibility and your selectability options. Every object in Comosys has visibility as well as selectability. So I turn on the visibility and the selectability of the floor polygons. And when I do that, these orange polygons appear on the screen. And these are what we call the load transfer polygons. They can be double clicked. They have their own property editor, which we will talk about. They have multiple, they have properties according to which the load can be transferred in both directions or in one direction. If then according to your need, you can, for example, double click on that and you can change the load distribution to two-way rather than one-way, or you can bring it back to one-way, or you can keep it automatic depending on your needs. But this is what the load transfer polygons look like. And now I will talk about how you actually go about creating them. So here I am on this floor. The level of this floor is 15,900. And I want to create those orange polygons you just saw on this floor. So what I do is I go to this floor menu on the right side, on the left hand side, and I create a floor called 15,900. The name can be anything actually, but I'm just giving it the same name as the view so that I can recall it easily. And it appears over here in the list of the already existing floors. And now all I need to do is I go to my frame load command. I can do it from here, or I can just right click from here as well. They both lead to the same place. But if I go from here and I say, okay, the relative level from this level will be 0. So this is at 15,900. I don't want to give it any offset, so 0 is okay. And then it asks me for which floor from the ones created on the left hand side. And if I go all the way down, I've just created this new floor, 15,900. I say okay, and the moment I do that, these orange polygons are created. It basically goes and finds all the possible combinations where loads could be transferred in this building. So let me turn on the beams like that so you can see it more easily. It finds every possible area where you could have a load transfer. And for that possible area, depending on how the releases of the elements are, it also suggests a load transfer direction, which you can then modify later. You can convert all of them to two-way or all of them to one-way. You can change the direction of which direction you want to apply the loads. But the whole point is that without you having to even select any points, it will create these polygons for you. And then what you can do is you can actually delete some of these polygons. And you can say, okay, I don't want any loading over here. I don't want any loading over here. This is a hole, I know that, in the floor. So you can actually go in and actually modify this list according to whatever your architectural requirements are. Once you have removed the floors, which represent, removed the floor polygons, which represent, which have covered areas which are supposed to be holes in the floor, for instance, you can go ahead and modify the loading, the transfer directions. So, for example, if I wanted to change all these into two-way distributions, I could just select them, select the floors by the on-the-fly filtering, and then go in there and say I want these to be two-way as well, and those would be converted into two-way. You can do, or you can do select the whole floor and do that. Now, once you're happy with that as well, now the time comes to actually apply the loads through these floor polygons. Now, to do that, all you need to do is just go to the floor polygon, which we have created at the 15,900 level, right click and say, I want to create a surface load using these polygons. And you select that option and this little dialog box appears. You can select a load case. So let's select the live load case, for example. And the direction can be, you can have global X, Y, Z directions, or you can say perpendicular to polygon. So like I said, you can do wind loads on roofs or any inclined surface. So in this case, I'm going to leave it at global Z, and I'm going to give it a name. I'm going to say live load, and then I'm going to give it a value according to these units. So let's give it a value of -5 kilonewtons per square meter for these floor polygons, and say OK. And when it says, do you want to create the surface loads? Yes. And the moment I do that, if I open this up, this little live load has been created on that floor. Now, if I were to then sort of rotate this around and look at it like that and turn on my live loads from over here, the reason why they didn't show up is because the visibility of the loads is off. So if I turn on the visibility as well, you will see that all the live loads have been created from those floor polygons. And in what amount? What is the quantity? That quantity depends on what you just did in there, whatever number you just gave. You can go in and change that number now if you want. I just wanted to show you how easy it is for a very complicated floor like that to create your loads. And even now, after you've created your loads, you can still go in and, for example, delete certain polygons. And when you do that, the floor loads will be modified accordingly immediately as you delete the polygons. So let's say somebody tells me that even this part doesn't have a flooring on top of it. When I do that, you see that the loads are being modified as we delete those polygons. So this is a very easy way to create your floor loads. Here is an even more complicated case of you can see the building on the left, and on the right hand side you can see the floor polygons at this level, which is the 8,550 level. And if I were to turn on the loads, you could see that all the floors, we have removed the polygons where there are openings in the floor, and you can see the openings are very complicated in this case, much more complicated than the example I showed you before. But the floor polygons have been used very efficiently to create basically your floor loads. Now, if I were to go in there and select a certain group of these floor polygons and press enter, and through the on-the-fly filtering, if I were to double click on the polygons only, I could just ask them to, so right now they're transferring the loads in both directions. If I were to say, okay, instead of the two-way action, you can, I want to give to create a one-way action for these particular floor polygons, and I do that, and then I go to this floor level and I say just recalculate the loads according to this new definition. When I do that, immediately the floor loads will be recalculated according to the new load transfer direction. Now, if you were doing an earthquake analysis, say based on the equivalent static load method, what you would do is you would find the equivalent static loads at each floor level and apply them as horizontal loads on the, say, the columns directly at certain node points, and that will give you the overall impact of the equivalent static loads on the foundations and on the braces, etc. But we know that in reality, the earthquake loads actually stem from the accelerations of the mass inside the floors. So it's not correct to actually just assign them to the columns directly. Just like it's incorrect to assign wind loads directly to the column, they're actually coming through the girts or the purlins. Similarly, the earthquake loads are also coming through the mass which is available inside the floor, and through the live load participation which is once again present inside the floor. So what you can do with these polygons, another thing which you can do with these polygons is you can ask it to create, say, another surface load, but this time you can choose a load case, of course. But instead of choosing the global Z direction, for example, let me choose the global X direction and call it the earthquake X load. Let's say my equivalent static load on this level is 10 tons, and the area of this whole thing is, let's say, 100 square meters. So that's like 0.1 tons per square meter. So I can actually go in there and say something like 0.1 kilonewtons per meter square, say, for example. This is my earthquake load in the X direction using these polygons. And what I will, if I do that, it asks me, do you want to create the load? If you see on the screen, it has actually created horizontal loads using these polygons once again, wherever they are perpendicular to the beams. So let me turn the beams on. Whenever they're perpendicular to the beams, they have been created as lateral loads. And whenever, for this beam, for example, over here, it's being applied as an axial load directly inside the beam. So it'll end up as the same 10 tons which we wanted to give to the columns, and the columns will receive the total of 10 tons, and that will be transferred to the vertical braces and from there to the foundations. But the actual small moments which in real life do occur on these beams as M22 moments, for example, and all the loads in these horizontal bracings, etc., will actually be much more realistic if you apply the loads in this fashion. Now, as I had said, these floor polygons are not really restricted to floors. The name is floor polygons, but they can be used on any plane in space. The plane can be an inclined plane, it can have whatever orientation. So over here, I have created a roof plane. This plane, as you can see on the left-hand side, it's an inclined plane. And on this roof plane, I've created a view. And using this view, I'm going to just ask the program to create the polygons for me. And I'm going to give it a level of 0 because the relative distance from that view is 0. I'm just going to say OK. And immediately you see these floor polygons are now created on the roof plane. And I have filtered out the sag rods and the horizontal bracings from this view because I don't want the polygons to be broken at those levels or at the roof bracing levels. And because I've done that, now these floor polygons conveniently are located between the purlins, and they will distribute the load left and right of the purlin. And now that I have the polygons, I can once again conveniently take them and I can right click and say create surface loads. I can say, for example, I want to create a snow load. I will say perpendicular to polygon this time because the polygons are inclined, and I want to create a load which is, let's say, the roof wind load. I shouldn't say snow load, but snow load is vertical. But let's just put it in snow load for the moment. Let's give it a name, roof snow, and assuming that it's actually in the direction of the wind. But I'm going to give it a value of 1 kilonewton per meter squared. And the important thing is it's perpendicular to the polygons, and that's what I wanted to show. So when I say OK and it's created, the snow load option is open. And as you can see, the roof loads have been created perpendicular to the polygons, as you can see over there. And if you can also notice, the last purlin got lesser load because the tributary area was less from the left, and the other ones got the same load. So these floor polygons are extremely convenient to create all sorts of load. You can use them to create wind loads, snow loads, live loads, earthquake loads in the X and Y directions. Basically anything which resides on a plane, you can use these polygons to create. Now, without wasting too much of your time, I want to move on. So I'll just show you that there are obviously, you can assign joint loads. You can select any joint and give it a joint load in the form of forces or moments. You can assign joints displacements as well. We'll talk about them later. You can assign frame loads. So if you were to select any particular frame and you went into the frame load command, you can actually assign uniform loads or concentrated loads or trapezoidal loads or temperature loads, and you can, for each one, you will have different parameters to enter in the dialog box. And you also have these other ones which we talked about. I won't be talking about the area loads which are applicable on shells, or area loads or line loads or point loads on shells. We'll get to them when we talk about shells. But the whole all kinds of manual loading is possible, and you just need to know that at the moment. So I just want to move on to the to the next topic.